Hello everyone. Today let us start our discussion on the problems. We have to do some problems on gravitation. Okay. We have derived the expression for the orbital velocity and then escape velocity, time period of time period of the satellite, and all those things we have derived. Based on that, we have to do some problems. Okay. So in this video, I am going to solve some 3 to 4 or 4 to 5 if the time permits. I don't know how many problems I am going to solve in half an hour. Okay, I will do some problems on the gravitation. Okay, let us start one such problem. Okay, I'll write the problem here. You can write it down. The first problem is a satellite is moving around the earth. A satellite is moving around the earth. Okay, a satellite is moving around the earth at a height of 900 kilometers. 900 kilometers from it. 900 kilometers from it. Calculate its orbital velocity. Calculate its orbital velocity. Taking the Earth's radius to be 6,400 kilometers. 6,400 kilometers and G is equal to 9.8 meter per second square. 9.8 meter per second square. So this is the problem given to you. What is your aim? Your aim is to calculate what is the orbital velocity of the satellite. Orbital velocity of the satellite, which is moving around the earth at a height of 900 kilometers. Okay, and a satellite is orbiting around the earth at a height of 900 kilometers from the center of the earth. Okay, you are asked to calculate what is its orbital velocity. Okay, and you have to take the other values given. The Earth's radius is 6,400 kilometers and G is 9.8 meter per second square. Okay. Let me write all these values here. H is equal to 900 kilometers. 900 kilometers. That means 900 into 10 to the power of 3 meters. 900 into 10 to the power of 3 meters. Okay. And then G is equal to R. Capital R. Radius of the earth is equal to 6,400 kilometers. That means 6,400 into 10 raised to 3 meters. And then G value is given, which is 9.8 meter per second square. So these are the values are given, and you have to calculate what is V naught. V orbital VO. Okay. VO is the velocity, orbital velocity. So these are the values given, and V naught you have to find out. So what is the formula? We have derived this formula now. So orbital velocity V naught is given by V naught is equal to square root of GR square divided by R plus H. GR square divided by R plus H. So now what is your aim? G is known, R is known, h is also known. Just support the values. These values you have to substitute in the given equation and using your calculator simplify it. You will get the answer for this question. Okay, and this problem. So I write the values. Square root of 9.8 into r is 6400 into 10 raised to 3 whole square. Okay, this whole thing divided by 6400 into 10 raised to 3 plus 900 into 10 raised to 3. So this is equal to square root of 9.8 into, I can write it as 10 to the power of 5, 64 into 10 to the power of 5 whole square. 64 into 10 raised to 5 whole square. This whole thing divided by, I can add here 6400 plus 900. We are going to get 5300. Okay, 5300. Okay, so 5300 into 10 raised to 3. 10 raised to 3 is common. Okay, 10 raised to 3. Or this whole thing is equal to 9.8 into 64 into 10 raised to 5 whole square divided by 53 into 10 raised to 5. Now you can simplify this. Okay, you can simplify this. If you simplify, you will get the answer as, sorry, here is 7,300. 7,300. 6,400 and 900. It is 7,300. This is 73 and 10 raised to 5. And the answer is 7415 meter per second. 7415 meter per second. Okay. And if you write it in kilometers, let's say this is velocity. You can put it in terms of meter per second only. So this is the orbital velocity of the satellite, which is orbiting around the Earth at a distance of 900 kilometers from the surface of the Earth. Very simple problem. This problem solve 5 marks. Okay, if the problem is given in examination, the marks awarded will be 5 marks. Okay, it's very simple problem. Okay, work out it. Okay, we'll go to the next problem. Second problem. So second problem is a sphere of mass. Second one, a sphere of mass. A sphere of mass 19 kg. 19 kg is attracted by another sphere of mass 15 kg, 150 kg, sorry, is 150 kg, when their centers are separated by a distance of 0.28 meter. 0.28 meter with a force equal to the weight of equal to the weight of 0.25 into 10 raises to minus 5 10 raises to minus 5 kg weight. Okay, kg weight. Now you are asked to calculate the gravitational constant. Okay, then if the distance is half, what is the new force? So this is the problem. Okay, what is the new force? So you have to calculate what is the gravitational constant. First we have to calculate what is gravitational constant. What are the parameters given? The parameters given are the sphere of mass 19 kg, let me call it as M1 is equal to 19 kg. M1 is equal to 19 kg. Okay, he is attracted by another sphere of mass 150 kg. Let me call it as M2 is equal to 150 kg. Okay, they are separated by a distance of 0.28 meters. So what is the distance of separation? I call it as say for example, I take D as the distance. D is equal to 0.28 meters. Okay. What is there with a force equal to the weight? This is the force between these two bodies. Okay. So F is equal to 0.25 into 10 raised to minus 5 kg weight. Then we have to calculate what is the G value. And then in continuation of this problem, if the distance is half, if the distance is d2 is equal to d by 2, then what will be the force? I call it as F2. I call that this one is F1. The distance is d1. Okay. If d2 is equal to d1 by 2, then what will be F2? New force. What happens to the force if the distance between the two bodies are reduced by 2 times? Okay, reduced by 2 times, or the distance is decreased to half. Okay. Now, as you know, the Newton's law of gravitation we have to take. That is F1 is equal to, that is the formula, G into M1 M2 by D1 square. Right? Our aim is to calculate what is G. Therefore, cross multiply this. G is equal to F1 D1 square divided by M1 M2. Just substitute the values, and then you will get the answer for this. Okay, answer for this. So F1 is 0.25 into 10 raised to minus 5, and the distance is 0.28. Okay, whole square. This is divided by M1 is 19, M2 is 150. Okay, 150. So you have to simplify this and you will get the answer for the problem. Okay, and the answer is 6.877. 0G value is 6.877 into 10 raised to minus 11. Okay, the unit for this Newton meter square. kg inverse square. Okay, this is the value of G. Okay. Now, if the distance is reduced, what will be the force? Okay, that means d2 is equal to d1 by 2. Okay, d1 by 2, that is 0.28 divided by 2, that is 14 meters, 0.14 meters. If this is the distance, what will be the force F2? With this G value we have to substitute here. That's all. Okay, F2 is equal to G into M1 M2 by D2 square. Okay. Now G is 6.877 into 10 raised to minus 11 into what is mass 19 into 150 divided by D2 is 0.14 whole square. So this will be the new force. The new force works out to be 1 into 10 raised to minus 5 kg weight. Okay. The first one is force, that is 0.25 into 10 raised to minus 5 kg weight, and the second one is around 1 into 10 raised to minus 5 kg weight. So this will be the answer. Is it clear now? Okay. ಬರ್ಕೊಡ್ರಿ ಇದನ್ನ. ಓಕೆ, ಮುಂದಿನ ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ತೀನಿ, ಮೂರನೇ ಪ್ರಾಬ್ಲಮ್. So third problem, calculate the period of artificial satellite revolving at an altitude at 200 kilometers from the surface of the earth. Okay, it is given the radius of the earth as 6.36 into 10 raised to 6 meters. It's given in terms of meters, not in kilometers. Okay. So with this we have to calculate what is the time period of the satellite. First you note down the values given. Radius of the earth is given, that is 6.36 into 10 raised to 6 meters, and height is given, height from the surface of the earth 200 kilometers, that is 200 into 10 raised to 3 meters. So what happens to the radius of the satellite orbit? Radius of the satellite orbit becomes, suppose the earth is here, if you call this as a And from the center of the earth we have to take, this is the orbit of the satellite, artificial satellite. Okay, imagine this. And from the surface of the earth, the satellite is here revolving. It is around 200 kilometers. And this is the radius of the earth, r. So what is the total distance from the center of the earth? We have to take small r. Small r is equal to r plus h. Okay, small r is equal to r plus h we have to take, right? Then time period is equal to t is equal to circumference divided by orbital velocity. So what is orbital velocity? Orbital velocity formula we know. This is circumference is 2 pi r divided by, okay, orbital velocity is square root of gr square divided by r plus h. So we have to substitute all these values in the given equation. So 2 into 3.14 into r is 6.36 into 10 to the power of 6, and here is you have to convert this. I have to write here r is equal to r plus h. I will write here 6.36 plus 200 into 10 to the power of 6 plus 200 into 10 raised to 3, okay, divided by this we have to take square root of gr square 9.8 into r is 6.36 into 10 raised to 6 whole square, okay, divided by this one 6.36 into 10 raised to 6 plus 200 into 10 raised to 3. Okay, then you have to simplify this. Simplification. So this is 2 point, p is equal to 2 into 3.14 into, I write it as 0.2 into 10 raised to 6. I write it as 0.2 into 10 raised to 6. Then 6.36 plus 0.2 common, 10 to the power of 6 as common, 10 to the power of 6 as common outside. Okay, and this is 9.8 into 6.36 into 10 raised to 6 whole square is under square root. Okay, and this becomes 6.36 plus 0.2 into 10 raised to 6. So one more step I will add here, 2 into 3.14 into, this becomes 6.56, so into 10 raised to 6. Okay, divided by square root of 9.8 into 6.36 into 10 raised to 6 whole square divided by, this becomes 6.56 into 10 raised to 6. Okay, you can cancel here by 1 times and you will get only 6.36. Take the square root and then simplify. You will get the time period. Write the answer for the time period. 5305.5 seconds. So this is the time period of the satellite which is orbiting at an altitude of 200 kilometers from the surface of the earth. Okay, so 3 problems are given. Okay, more problem ಈ ವಿಡಿಯೋದಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀನಿ. ಇನ್ನೊಂದು ವಿಡಿಯೋ ಮಾಡ್ತೀನಿ. ಇನ್ನೊಂದು ವಿಡಿಯೋದಲ್ಲಿ ಎಷ್ಟಾಗುತ್ತೋ ಅಷ್ಟು ಮಾಡಿ ಅರ್ಧ ಗಂಟೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವಿಂಗ್ ಸೆಷನ್ ಇಟ್ಕೊಳ್ಳೋಣ. ಯಾಕೆಂದರೆ ಜಾಸ್ತಿ ಇಟ್ಕೊಂಡ್ರೆ ನಿಮಗೂ ಕೂಡ ಡೌನ್ಲೋಡಿಂಗ್ ಅವೆಲ್ಲ ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತೆ. ಆ ಕಾರಣಕ್ಕೋಸ್ಕರ ಚಿಕ್ಕದಾಗಿರುವಂಥ ವಿಡಿಯೋಗಳನ್ನು ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. ಸೊ ಇದರಲ್ಲಿ 3 ಪ್ರಾಬ್ಲಮ್ ಹೇಳಿದ್ದೀನಿ. ಇದೇ ಟೈಪ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ನಿಮಗೆ ಮೇನ್ ಎಕ್ಸಾಮಲ್ಲಿ ಕೂಡ ಕೇಳಬೇಕಾಗ್ತದೆ. ಸೊ ಹಾಗಾಗಿ ಈ ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಚೆನ್ನಾಗಿ ವರ್ಕೌಟ್ ಮಾಡಿ. ಓಕೆ, ಮುಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ ಇನ್ನೂ ಅಷ್ಟು ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ನಾನು ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.